Hey guys, Jay Wilson here. I wanted to make a quick follow-up video to the tutorial I just posted about inventory replenishment adjustment. And the reason why I'm making this video, well, first off, welcome to the channel if you're new to the channel. My name's Jay Wilson. I'm a freelance consultant on the Domo platform. I like trolling around the Domo dojo to answer questions that people have. Subscribe to the channel, like the video, send me an email at jae@onyxreporting.com. Yeah, I'd love to hear from you. Today, in this follow-up video, I want to talk about blocking functions. In a nutshell, blocking functions are the reason why some activities, some data flows in Domo take forever, and on the same input set of data, other transformations are super fast. So we're going to talk about blocking functions. This is not something new. This is something I didn't invent. You can literally Google SQL query blocking function. It will give you more information. But I wanted to talk to you about it in the Domo context. Now, the reason why I even thought of this is I was doing my write-up for the tutorial video, and I started with, I hate to say it, but I think you're going to have to use Magic ETL. That's where I started my sentence. And it's not that Magic ETL is bad. And it's not that MySQL or Redshift would do this any faster. In fact, I'm pretty sure Magic ETL will outperform both of them for the data flow that I designed. I think that's true. So why did I say I hate to say it, but? The answer is blocking functions. Rank and window are what are called blocking functions. But in order to understand that, let's talk about what is not a blocking function first. A non-blocking function, or let's just call it normal. A normal function lets you process the data as it arrives and then pass it on to the next step. So consider something like text formatting. Let's say I've got a data set and I want to take a column and make it uppercase. Well, as one row of data arrives, I can just process it and send it on to, I need to point the camera down. I use my hands a lot. I'm feeling Italian today. I don't know. As one row of data arrives, I can process it and pass it on to the next step. And so the next step happens to be, well, you're going to add a constant called test with the date 5/26/2020. I can take that row of data, process it, and move it on to the next step without any wait. I don't need to know what was the previous row value. I don't need to know what is the next row value. I don't care. I can just process the data as it arrives. So it just flows through like a fire hose in a stream. Imagine this is why do we care? The reason why we care is imagine that this is a 1 million or 100 million row data set. Now, we all know how Magic ETL works, right? Magic ETL is not a SQL environment, which means data gets transferred from Vault, the storage environment, into the Magic ETL engine, chunk by chunk. And as each chunk arrives, I can just start passing it through my data flow. So basically, I can start writing data before all of the data has even gotten into the system. And so data flows like this will be very fast. I mean, yeah, you still have to load and process 100 million rows, but relatively speaking, it will be very fast. Now let's compare it to this transform here. Let's assume that I still have the same 100 million rows. This will be a lot slower than this. Why? The answer is blocking functions. So what is a blocking function? A blocking function means I cannot finish the transformation until I have all of the data. I am blocked from moving on to the next step until all of the data has arrived. So in our example, if I have 100 million rows of data, I literally cannot move past this point until all of the data has arrived. So let's think back to our cumulative sum example, right? In order for me to calculate a cumulative sum, I have to know that I have all of the data. Not only do I have to have all of the data, I have to have sorted the data, and that's the part that kills. Sorting large volumes of data is just terrible. Like if you were a human, or if the computer was a human and you said, hey dude, I've got 100 million rows, and what I want you to do is I want you to calculate a cumulative sum. And you're like, okay, fine, but I guess I have to order 100 million rows by date before I can calculate the cumulative sum. I have to have all of that data before I can comfortably move on. And so let's look at this window function. The sum part is easy, but it's that frame here. This is what kills. It's not just sum. Think about rank. Rank is a reflection of the same thing. If I say, oh, I want to rank by total sales. Okay, well, first you have to calculate all of the total sales rows. Then you have to sort them. Then you can rank them. Same for row number. In order to calculate row number, I have to know all of the data. I have to sort it somehow, and then I can apply a row number. Lead and lag, they're all, basic permutations of the same problem. I have to have aggregated all the data first, and in most cases, I have to sort them. So in this example here, I'm sorting by batch last run date. In the tutorial video about inventory, we sorted by activity date. Fine, but the point is you have to sort by date. What if we had partitions though, right? Again, in our tutorial, in our inventory example, we didn't have multiple customers, we didn't have multiple products, but what if I had multiple products and customer permutations? Now I'm telling the system, hey, all this 100 million rows of data that's arriving, you need to split it into 5 or 6 little subtables that are then sorted by date before I can do that cumulative math. Blocking functions are super expensive. And so it's functions like this, it's functions like the group by clause, it's functions like some of the pivot and uncollapse that really add time to some of these ETLs. And that's why I try to avoid them if I can. Okay, but let's assume you can't avoid this blocking function. Now I've got a choice. Let's assume my choice is either first I can do my text formatting, then I do my rank. Or what if I had the choice and I could say, oh, I'll do my rank and then output. Which data flow permutation will be faster? On average, guaranteed, on average, this implementation will be slower than the other way around. Especially if I have more stuff after this point. Why will this be slower? Because the block appears early in the query. I literally cannot move on to the next step until all the data has finished processing in this window function. In the other permutation, here, I can process each row as it arrives and then put it into the window function. And so by the time all of this data is loaded, all of this data has been accumulated with the text formatting applied, and then, yeah, it takes time to write the data to disk, of course. But this implementation here, on average, will be better than the other. Why are we having this conversation? We're having this conversation because I started by saying, I hate to say it, but you have to do this in Magic ETL. Check one. It's not that Redshift or MySQL will be faster. Both of them will be relatively equally slow. In fact, I think Magic ETL would probably outperform Magic ETL, I'm comfortable saying that. Magic ETL would outperform both MySQL and Redshift for this task. I think. Pretty confident across any kind of data volume. So step one. And if I had my choice, my preferred implementation would say, hey, I'm going to do this in a beast mode, if possible. Now, for this use case, it was not possible, but if I could, I would do it in a beast mode. My second choice would be to use the data views beta feature that's coming out in the near future. Talk to your CSM about it. That would be my second choice. My third choice is if I had the tech available, if I had the adrenaline data flows, that's another beta feature that's coming out whenever it comes out. That would be my third choice. And absolute last, Magic ETL, and dead last, any sort of SQL version of this. Cool. My name's Jay Wilson. I'm a freelance consultant. I'm out on the dojo. You can email me at jae@onyxreporting.com. Subscribe to the blog if you liked what you're hearing. If you have any follow-up questions, let me know in the comments. Good luck. Catch you later.